Hey guys, I'm going to talk about our technical approach and implementation details of our N-body simulator. So we decided to base our project off of the cloth sim architecture because we wanted to make use of the camera and the simulate pipeline. So in simulate, we would compute the forces of each particle according to Newton's law of gravitation, and we would update the position and velocity using kick, drift, kick, leapfrog. And we chose this method because it's second order and it has this special property of time reversibility. And that means energy is conserved at each time step, which leads to very stable simulations. Computing forces between every particle is of order n squared, so if we want to simulate a large number of particles, we need a more efficient algorithm. We decided to use the Barnes-Hut algorithm, which is of order n log n. What this does is it subdivides 3D space into 8 different boxes called an octree, and this allows us to approximate the forces from one particle onto a cluster of particles by doing one calculation, as if it were a single particle located at that center of mass. And we do this if it meets a certain threshold, otherwise we'll just recurse down the tree and compute the forces between each individual particle. After implementing speedups in our simulation, we wanted to make things look prettier, so we added some shaders. The cooked horn shader essentially adds some microfacet behavior on top of a Bling-Fong model. And it does this by adding a distribution function, a geometry function, and a Fresnel function. We also have a planet shader, which is essentially just a noise function that adds some pseudo-random noise onto a sphere. And this kind of looks like solar flares, which is pretty cool. So this is going to be a quick demonstration of our GUI. So we can generate different particles systems. We can change the number of particles, say like 10, change the max radius, and then we can even do random masses, which is pretty cool. We can make more particles, let's say like 60. We can change the shaders, do like light. We can change to the planet shader, which, as we can see, these different random noise. And then we can simulate it. We can even change the simulation speed. You can also use the naive approach. And then there's even a Barnes-Hut visualizer, which basically allows you to visualize the octree. In conclusion, this project was really fun and rewarding. We learned a lot of things, such as the Barnes-Hut algorithm, destructors, memory heap, and a bunch of other C++ tricks. We also were able to get our hands dirty with CMake and OpenGL, learning how to compile different projects together, learning how dependencies work. We also looked into noise generating for shaders and a bunch of shader-related components such as diffusion. But most importantly, we learned realistic physical simulations are hard. When people make simulations of the universe in the real world, it's often a lot more complicated than what we did, and they often have to take into account factors such as dark matter or gravitational lensing. A couple future possible additions we could add are particle collisions. Currently, we just have a dampening factor that prevents particles from shooting off to infinity when they get way too close to each other. We could improve some speed up, such as threading or GPU acceleration like CUDA, to make it render more and faster. We could add like velocity constraints to prevent particles from going way too fast in terms of like collisions. And we can even add additional shaders, different planets and whatnot. Thank you guys so much for watching.